All right. We did example 1 yesterday, and it was a doozy. That one is online also. This will also be online, right? As long as you guys don't mess it up for me. Just kidding. All right. So example 2, very similar to yesterday. Use weighted average to partition a segment. Use weighted average to partition a segment. What are the coordinates of point P that partitions AB with the ratio 2 to 3? Now, first of all, what do we mean by partition? Reading about what it's saying, we're using weighted average to partition a segment. What are the coordinates of point P that partitions AB in the ratio 2 to 3? What do you think partition means? Anybody? Parts. Parting it. Parting it, right? Partition comes from the word part. So if it's partitioning, and it's a verb, we are splitting it into parts. Not separating it, but breaking it up into parts, right? So it's giving us a ratio of 2 to 3, which means it's not balanced. The weights are not balanced. Remember we talked yesterday about that tug of war? So we're in a tug of war again. And as somebody requested yesterday, we can call them teams. Team A and Team B.
Oh my God.
Okay? You can see from the line segment which team is winning, which team is stronger. Team A is stronger. Okay, so you can find P by finding the weighted average of A and B. Let's see how. The ratio is 2 to 3. So one part is 2, the other part is 3, if you're comparing the distances, right? That means that it's out of how many? If one part is 2 and one part is 3, the total is 5, right? So we can break our ratio up into 2/5 and 3/5. And that is how we can very easily get the weights. Remember yesterday where we had to multiply the 2 and the 10 by there, we figure out the weights first, and then we multiply. Okay, it's pretty much giving you the weights in a ratio form. And all you have to do is go, 2 plus 3 is 5, so it's a total of 5. So 2 out of 5 would be one weight, and 3 out of 5 would be the other weight. Now, just like we said, Team A is winning. Team A is stronger. So it gets the heavier, or here they say the larger weight. I call it heavier weight, stronger weight, larger weight. So I don't want you to be confused by this. Notice that the distance between A and P is smaller, right? So you're like, well, shouldn't this distance have the smaller fraction? No. Because we're not talking about the distance between A and P. We're talking about which team is winning, which team is the stronger team. Team A is stronger, it gets the heavier, larger weight, which is 3/5, not 2/5. So, to find point P, we're going to use our weights, 2/5 and 3/5, and our coordinate pairs. So yesterday, we had pretty easy values, right? One value was 2 and one value was 10. We multiplied the 2 times its weight. We multiplied the 10 times its weight. Now we have coordinate pairs. So we're gonna actually multiply a coordinate pair times its weight. And we're gonna multiply the other coordinate pair times its weight. And it looks complicated, but we're gonna work slowly and you're gonna see it's pretty simple, okay? As long as we set it up correctly and just fill in, we'll keep it nice and organized. finding point P means we need to combine the point A's coordinates with its weight and point B's coordinates multiplied times its weight, okay? So we're gonna sub in for A its coordinates, 3, -4. 3, -4. We're not solving anything yet, we're just substituting our coordinate points with its coordinate pair. The coordinate B is the pair 3, 11, it's given information. So we have 13, 11. And I know this is weird, we're like gonna distribute the weight to the coordinate pairs? Yeah, because each value, each x and y value is a part of it, so that weight affects both coordinates. So we're gonna distribute, and you know I always draw my arrows, even if I have to draw them really tiny and I can barely see them, but it just makes me feel better and more organized. So we're gonna multiply 3/5 times 3 and get 9/5. Then we're gonna distribute 3/5 times -4 and get -12/5. If anybody wants clarification, just slip your hand up and let me know what you want me to go over. We're rocking and rolling, right? Now that we got through yesterday's problem, it's like a little more simple. We're just applying it to coordinate points instead of the values 2 and 10 on that number line. Yes?
On the phone, there was a question that was like the other one, but it was like back.
Okay.
I said like,
so you'll be able to do.
Besides weight was 3 times more than that, both.
Okay, so you would be able to figure out those weights the same way that, so it was with coordinates, but it also gave you the weights and like comparing them. So you would use the strategy yesterday to find the weights by making them equal the whole thing, equal 1. Then getting your fractions would be your weights. So sometimes you'll be able to find your weights if they give you a ratio, and sometimes you'll be able to find their weights if they say point T is 3 times closer or 3 times heavier or something like that, okay? So we're gonna distribute our B coordinate, or I should say the weight of the B coordinate to each value x and y. We have 2 times 13 is 26 over 5. I know I'm kind of breezing through the whole multiplication of whole numbers and fractions, but we don't need to go over that, right? If you need me to go over that, you let me know. 2/5 times 11 is 22 over 5. Now, we're still going to add them together. So, what we do is we add the x coordinates together and we add the y coordinates together. It's kind of like combining the like terms. It's kind of like combining the like coordinate terms, okay? And that's why they wrote the x coordinates in red. So if these are your x coordinates and you want your x value of point P, you have to combine the 9/5 and the 26/5. So we'll get 35/5, which thankfully divides and makes a whole number 7. Now our y coordinates, -12 over 5, 22 over 5. Combine those together, you get -12 plus 22 is positive 10 over 5. And again, we can divide and get the whole number 2. I'll give that a chance to sink in, and you guys can get these notes down. And then I think we'll do a try it problem.
Yeah, this was easier than yesterday.
Yes, because we needed yesterday though, right? We needed yesterday to understand it. Yeah.
Shout yourself out in Mother Grandma's kitchen.
No, I shouldn't,
Why?
because that one's asleep.
Oh.
I don't broadcast that one to my students. Somehow you guys came across that.
That was Maddie.
That was Maddie, and we don't talk about Bruno, okay? Not that there's anything wrong with that channel, but it's not something that I promote, okay? All right, any questions about this so far? Are we following this? Lots of steps, that's why we take our notes, okay? Can I move on? Do you want to try the try it problem?
Yeah.
Oh wait, it doesn't give you a try problem. It gives you another example. Okay, let's do that. Okay, this is actually so easy, I love it. Right, you saw the ratio, right? The ratio is 1 to 1. Yay! If the ratio is 1 to 1, what are we really finding here? The middle, we call that the midpoint.
P.
Sounds like we're about to learn the midpoint formula.
Oh, I remember doing that.
Right?
Really easy.
Right? But we're using our weighted average, which the weight is equal, the scale is balanced. Then we're gonna kind of be like, oh, that's cool. You can find the midpoint that way. Okay, so this is a lot easier, right? What are the coordinates that of P that divides the segment, CD, into two congruent segments? What does congruent mean?
That's a funny question. Same, similar.
Equal, right? Equivalent, congruent, they're the same distance, okay? Since CP is equivalent to DP, P partitions, breaks up, CD in the ratio of 1 to 1. That's not really weighted, is it? It's just the average, right? It's just the midpoint. So the weights are both half, because remember, the entire weight has to equal 1 whole, right? So if they're equal weights, then you've got half and half, and we like those, right? Find point P. Look how nice and easy this is. Half of point C plus half of point D, then all we have to do is sing it. Sing it.
No. No.
Thank you.
No.
Bonus points. Bonus points over there. Oh, you know what? Here you go. Here's your bonus point.
I'm the one
There
who
you go.
said it.
I said to sing it.
Plug it in, plug it in, plug it in.
Can I just get markers?
That was terrible.
I didn't hear you. You want to sing it? Okay. It's like not on camera.
You got a blue one? Second.
Will you sing for the blue one?
Plug it in, yeah.
All right.
I sang it.
That was so beautiful. He really tried, guys.
Yeah, I really tried.
Okay. Moving on. We're plugging in our coordinate pairs, okay? We're plugging in our coordinate pairs. For C, it's -5, -4. For D, it's +4, -2. I am going through this one a little bit more quickly, and it's because it's a little bit more simple, and it's the same process from here on out. Okay? If you're feeling like I'm going too fast, watch the video later. All right, so we've got half times -5, -4, distribute, plus half times +4, -2. We're distributing, we've got -5 over 2. 1/2 times -4 is -4 over 2. And we'll just keep going before we start simplifying that. We'll just keep going and make it nice and neat. 1/2 times 4 is 4 over 2. 1/2 times, those are really wonderful notes, but I would love them to look more like in the form of numbers, okay?
Yeah, that's probably a good idea.
Yes. 1/2 times -2 is -2 over 2. Then we can start simplifying, and if you want to simplify like in the process, that's fine. Okay, -5, oh well, oh no, you know what? We don't want to simplify yet. And I know why. Do you guys know why? Why we didn't want to simplify right away?
Why?
Because we're adding our x coordinates and our y coordinates together. So since they're all common denoms, we want to keep them common denoms. We don't want to be like, well, that equals 1, because we have to still combine them. So we're going to combine our x coordinates, common denom, so we just have negative 5 plus 4 is negative 1 over 2. Combine these, common denoms, negative 6 over 2, which would be negative 3. And so, this is the fancy way of saying it. Therefore, the point P, negative 1/2, comma, negative 3,
No,
divides segment CD into congruent segments. We say that P is the midpoint. Oh, there's our vocabulary word. Midpoint of CD. Boom. All right. Do you want to keep going or do you want to try
Keep
one?
going. Keep going.
Okay, keep going. Oh, look, the midpoint formula. Isn't that adorable? Okay, the midpoint formula, the midpoint. This is vocabulary, that means you write it down. That means your notebook's open and your pencil's in your hand and you write it down. Oh, you got it, okay, not bad. I couldn't see because you're.
Didn't we do this last year?
I think we actually did.
I'm
So,
surprised I remember.
Merry Christmas, it's review.
Oh,
okay?
no, we did something different. We did x.
Good job.
x2 minus x1.
Oh, yeah.
So, the shortcut is a formula. Because if a midpoint of a segment is a point that divides it in half, so that the point is in the middle, then the formula of the midpoint formula of 2 points is really all you have to do is find the average. Remember, because in the middle, it's the average, not weighted. The middle would simply be your average of your x values, comma, your average of your y values. We'll put this into practice in just a second.
You got a highlighter?
I do, actually. It's just about like where my highlighters at. Oh, I found them.
Oh, yeah.
Open it up, and if anybody else wants a highlighter, you guys can have them. I don't need them.
Nice.
Oh, they were so
I want this.
You want my pencil or my wrapper?
Wrapper.
Did I have a highlighter
You
on?
collect wrappers?
Which one do
You
you
want to
want?
recycle it, wrap?
I want the yellow
I
one.
claim the pink and blue one.
I want the yellow one.
All right, whatever. Let's just speed it along.
Alright.
Everybody good with this formula?
Yes.
We are finding the average of the x values and the average of the y values. And guess what? It's on your UMC reference sheet.
What?
What?
Can we write on it?
Yeah.
Whoa.
All right, so question 3. What is the midpoint of segment AB? Substitute the coordinates of the endpoints into the midpoint formula.
Oh.
I like to write my endpoints on top of each other, and I'll show you why. Okay, I'm gonna say A is negative 3, 2, and B is positive 4, negative 2. And the reason I line it up like that, because then I have my X and my Y, sorry,
That's so small.
I have my X and my Y all lined up for me. Whoops, sorry. So when I want to find my average of my X's, I just grab my negative 3 and my 4, add them up, divide by 2. Are you allowed to cancel this 4 and the 2 first? No, sirree, Bob. We add them, we divide by 2, so we have 1/2. My Y values are all lined up, positive 2, negative 2, 0 over 2, what's that?
0.
0, remember when we were panicking yesterday
mhm.
about getting a 0?
You mean I was panicking?
Yeah, you were panicking and I was trying to calm you down, okay? Because remember that 0 is a value on the coordinate plane.
That's great.
Yeah, right, it's okay. It's okay if you get 0 as one of your x or y coordinates. And boom, we have the midpoint. See how I feel it's getting easier? Yesterday was like, really? This is my dance where it's getting easy, guys. Alright.
That doesn't make sense. The line doesn't go.
Happy it's easy and don't like
So the, yeah, so the midpoint is half. Half on the x, which would be here, and then 0 on the y. You're trying to catch the book's mistakes. I wonder, do you ever catch a book mistake? I'll buy you ice cream.
Really? What? Wait, I want ice cream.
Alright, I want you guys to, do you want to try the midpoint one?
No.
Let me see how many more examples.
That's a lot of examples.
Yeah.
Wow.
Alright, distance formula. Distance formula is also in your EOC reference sheet, okay? I'm gonna be able to get through all of these today, if you guys are with me, okay? And honestly, you can try those tries on your own, and it's interactive, so it will tell you if you get it right or wrong. But they'll also be on your homework, okay? Speaking of homework, 1.3 is due tomorrow. Alright,
Tomorrow morning, right?
tomorrow morning by 8, yes. Okay, so if you wanna wake up at the crack of dawn and work on it, that's fine, get it submitted by 8. Alright, distance formula. This is actually like, another formula in disguise. See if you can figure out which one it is. Oh yeah, okay, it's up in B, already knows.
I've already
It
done
says
this.
it on the.
Okay, have you done distance formula before?
Not the formula, but I've done
Okay, because we recognize that when we have a right triangle, and we're trying to find one of the sides of the triangle, especially if it's the hypotenuse, we automatically think Pythagorean theorem, right? We definitely did that last year. We have that beautiful poster to prove it.
What's a Pythagorean?
Show the camera.
I'm kidding, I know what it is.
Okay, oh my gosh. Okay, back to the problem. Derive the distance formula. Derive, figure it out. How can you find the distance between point P and Q on the coordinate plane? Okay, so we've got a diagonal line, and we're trying to find the distance. Okay, this is more just like the theory behind it. We don't actually have coordinate points. Sometimes these look more complicated than they actually are, but it is showing you how the formula is derived or created. Okay, the distance, D, relies on the horizontal and vertical change. So this distance, since it's not parallel with the x or y axis, its distance relies on its relationship with this distance and this distance. Do you guys agree? It relies on that relationship, okay? So, notice the right triangle?
Yeah.
Right there, notice it?
The square.
So, yeah. Okay. Apply the Pythagorean theorem. So what we're really doing is taking the distance of this, right? We'll call that A. The distance of this, we'll call that B, because A and B are our legs. We square those,
Legs.
and we get, up here please, we get the distance of D, also known as C in the Pythagorean theorem, and that's also squared, because we know C squared equals A squared plus B squared, or the other way around, A squared plus B squared equals C squared. So you know that eventually, when we are doing the Pythagorean theorem, eventually to find out what D is, you have to find the square roots, right? So the distance formula is written like the Pythagorean theorem, except instead of showing D squared and then having to solve for the square root, it already unsquares D, or square roots D, and then shows the square root of A squared plus B squared. So it is a form of the Pythagorean theorem. It's a little bit uglier,
Yeah.
and it's much more helpful that it's, wake up! Thank you. It's much more helpful that it's on your EOC reference sheet, right? Remember, we're having a notebook check on Friday,
Uh-oh.
right?
All of
Okay.
this is on YouTube, so.
Yeah.
And all of it's on YouTube, so you can take notes at home. Isn't that great?
I have a lot of notes, just like,
Double the notes.
I don't,
That's
I don't
surprising.
know. I don't think you're gonna wanna read all my notes myself. Yeah, I have a lot.
I think it's just
Okay.
I use the highlighters.
Yes, very much for your.
One more problem. One more problem. Who likes baseball?
Call.
You like
do?
Violent
Colin
What's,
Hoover.
okay, that was creating a lot of giggles back there. She likes baseball because there's a boy involved, I'm sure.
Yeah.
Okay,
Uh-huh.
I know that giggle. Okay. So we've got some, did anybody else like actually play baseball in here? No?
Baseball?
No
Oh,
baseball?
no.
No, when I was
Okay.
in grade.
I actually really like playing baseball. I don't like watching it, but I like playing baseball. It's fun.
My dad played softball.
Softball, okay. So a pitcher who's here. Okay, we're done giggling and chatting. Now we're back up here.
Okay.
I love just like the face turn, like just shh, front of the room. The pitcher is right there because that's where the pitcher goes. He throws a ball to the batter. Boom!
Yeah.
Strike. No, just kidding. He throws the ball to the batter. And then the batter hits the ball. Boom!
Home run.
To the shortstop. If the ball travels in a straight line between each, which
Whoa.
makes sense, right? It might make a little parabola, but it's not gonna ziggy zag, right?
What?
If the ball travels in a straight line between each, now watch this, from the pitcher to the batter.
Bang.
The batter hits it from there
Field
to
goal.
the shortstop. Look at this beautiful line. What is the total distance traveled by the ball? The total distance traveled by the ball.
To there, to there.
So essentially, what are we gonna have to do at the
So
end?
you have to be there to there, and then there all the way up to there.
And then,
You find how much it went by adding it together.
yes, you bring them together. So they're not just asking for this distance, and they're not just asking for that. They want the whole distance. Okay. The total distance traveled by the ball. Round your answer. Remember last year it was all about those parabolas. How high is the ball gonna get? This year we're finding the distance. Round your answer to the nearest tenth of a foot.
When do we have to do it?
Now, zoom in for me, okay? Zoom in, get your zoom in magnifying glass on. Here's where it's gonna try to trick you. These units represent 9 feet.
No.
It's, you gotta read the fine print. It doesn't even say it there. It says they wanted to the nearest tenth of a foot. These units do not equal feet. 1 unit equals 9 feet. So what will we have to do at the end?
Multiply.
Yeah, multiply by 9. It's gonna be one of those things that you have to really look for, the fine print, okay? So we're gonna formulate. Represent the pitcher at point 5, 5, because here he is, 5, 5. So now we've got our coordinate points, 5, 5. The batter at point 0, 0, he's at the origin, right? And the shortstop at point S. Oh, we'll call that point S. Okay, so we're gonna call the pitcher P, we're gonna call the batter B, and we'll call the shortstop S, and then the his point will be 5, 10. Everybody following me?
Mm-hmm.
Now I feel like this is all gonna just go away,
Oh man.
right? I tried so hard to make it nice and neat. Okay. All right. We're going to use the distance formula to solve, okay? You're probably gonna need calculators. Anybody wanna grab a calculator?
I have a calculator.
Grab a calculator, pass them around if you need it.
It's not very fun. Stop making.
You don't like this one?
I don't like math.
Stop it.
It's like gross.
Thank you, thanks. It's really good for my audience,
Your audience
is you
is
guys.
proud of you.
Yeah, okay.
You're doing great.
I have heard people say, I don't like math, but I like math class. And I'm good with that. So let's go with that, okay? You don't have to like math, you're not gonna hurt math's feelings. But you have to like my class, or else I'm gonna cry right in front of you. And you know how I think crying, it looks really real, okay? So don't make me do it. Don't make me do it. Here we go. Here we go. Use the distance formula to find each distance. So, from pitcher to batter, we need, from pitcher to batter, we need the difference of our, I'm just gonna draw my right triangles here, okay? We need the difference of our x values and the difference of our y values, which happen to be the exact same thing. Because remember, I'm just gonna go back to that formula. The difference of your x values squared and the difference of your y values squared. In this case, it's the exact same thing. The difference would be -5, and -5 squared is what?
Negative 20.
No,
Well,
you
25,
fell
25,
for it. It's okay.
25.
I actually kind of wanted somebody to fall for it because we don't want to make that mistake, right? -5 times squared is -5 times -25. That's not, okay, 25, okay? So now we're finding this distance, right? From P to B, and we have from pitcher to batter, from P to B. The distance is 25 plus 25 is 50. Square root of 50 is approximately 7.1. Now we're going from the batter to the shortstop. We have to find the difference of our x values, 5 minus 0. And if you put 0 minus 5, that's okay, because square rooting it will always give it the positive. I mean, not square rooting it, squaring it. Okay, and then the difference of our y values. So 0 and 10 is going to give us 10. Can I erase this now?
Yeah.
Okay.
No.
You have to say no before I start. Okay.
Again.
So the difference is 5 squared is 25, 10 squared is 100. 25 plus 100 is 125. Square root of 125, again, you're going to need your calculators for these things, is approximately, that's why we have our like squiggly equal sign, approximately 11.2. And just like Zach said earlier, we have to add them together because we want the distance, the entire distance that the ball traveled from the pitcher to the batter to the shortstop. Okay? And then what do? You said it before. Because when you add these together, it's 18.3. Yay, we got the answer. No, we didn't. What did we have to do at the very end?
Multiply it by 9.
Cry.
I know
I
this
want
one.
me to
said
try
the answer.
Yes, yes. We can multiply by 9 because remember,
Oh,
boom,
yeah.
this fine print is trying to trick you. Don't let it trick you.
Multiply by 10 and then divide by 1.
You guys, we got through everything. Let's just review real quick. We've got our midpoint. And your reference sheet is on Canvas or in Canvas. So you have your midpoint formulas, your distance formulas. Okay? Here are your examples if you ever want them in your interactive student book. Do you guys want to work on homework? Yeah?
Can you film us working on homework?
You want me to go around?
Yeah.
I can't because I can't.
Is it legal?
I would laugh.
No, you have
All
to,
right, you
like,
guys go ahead and start working on
ask
homework.
our parents' permission to film this or something.
And raise your hand if you need help, because I will come around and help you.